All right, good morning for science 1, for science 3. Nice to meet you all again today. Today, this one is your first lesson. Okay, it's very early, 8:30 now. But I think it's good for you to wake up early, everybody. If you can wake up early, that means you can enjoy more time for you to study. Okay. Don't forget, now is still your school days until 18 December. It's still school day, not holiday yet. So many of you thought that now is already holiday. No, it's not holiday yet. No, it's still consider your school day. Your last school day will be on 18 December. Okay, so please maintain your good spirit at least until 18th of December lah. So wake up early, follow the online lesson. Okay. All right. Now for today, I continue our revision now. Okay, come, I share the paper with you. Okay. You cannot see the paper, so please let me know. Okay. We start with question number 3. Is it correct? Can you see the paper or not?
Can.
Then is it number 3? We start with number 3 now.
Yes.
Okay. Thank you, Ping Hao. Okay, let's look at the question number 3. You study the question first, everybody. A student running a 200 meters event. 200 meters, you see the distance here? 200 meters, right? Okay. Lima, yeah. Okay, so it's 200 meters event. All right, by looking at the graph, right, this student now finish up the 200 meters event in 24 seconds. You see here, 24 seconds. Okay. And there are 2 stages here, First stage, you see from O to A, right? This boy, this student finished 100 meters, but he took 14 seconds, which is quite long. First stage, he need 14 seconds to finish up the first 100. And then the second 100 meters, right, is here. From here to here is the second 100 meter. This student only need 10 seconds to finish up. So meaning that first stage here, the boy runs slowly. Then after that, the final 100, so he speed up. So he finish it in 10 seconds. Here, he need 14 seconds. So altogether, he need 24 seconds to finish the 200 meters. Okay, first question, which one is correct? Distance is what? Is scalar or vector quantity? Nicholas, can you answer? Distance is which one? Yes?
Scalar.
Yes, correct. Scalar. So please cross here. So distance is scalar quantity. Correct or not, everyone? Please focus lah. I know early in the morning you all feel sleepy. Okay, please stay strong and then stay focused. Okay, come next. Based on diagram, calculate the speed section AP. Find the speed AP here to here. How to find speed from the graph? How to find speed? Right? Okay, you see to find the speed, V, right? You take distance divided by time, correct or not? Distance divided by time. Okay, same as a gradient now. So you take this triangle here, right? Distance is here 100. Distance divided by time. Distance is 100. Here is 100. Very hard to write now, Time here 10 seconds. So distance is 100. Time is 10 So what answer you get? 100 divided by 10. So this is a speed for AP. 100 divided by 10. Okay. What answer you get? Aiman, are you here? Aiman, I saw your name there just now. Aiman, can you answer? Aiman, Aiman always cannot hear me. One. Michelle, what is the answer, Michelle? Michelle Chua, what is the answer?
10 meter per second.
Yes, 10 meter per second. Yes, you can see the answer here. Okay, 10 meter per second. You find the gradient 200 minus 100 divided by 24 minus 14. So it's 10 meter per second. Same as the gradient. Okay, so this is the answer for the section AP. All right, we move on. Next part of the question, they ask, compare the speeds of the student at OA and AP. They ask you to compare. So you calculate the speed at OA lah. Then only you compare. Same thing now, you find the gradient. Okay, for OA is here. 100 divided by here times 14. Okay, 100 divided by 14. So you get this answer. Okay. 100 minus 0 divided by 14 minus 0. The gradient now, 100 meter divided by 14 seconds, you get this. Okay. AP was 10, but now OA is 7.14. So meaning that the speed at AP is higher. They ask you to compare. Okay. So the answer here is speed at AP is higher lah. So you have to show the number lah, show your calculation. AP is 10. OA is 7.14. Therefore, AP, the speed is higher. Okay? Understand now, everyone? Then got it or not? Yeah, for those who just came in, I saw a few of you. Please send your attendance. Haris and so on, a few of you. Okay, send your attendance, please. You test. Okay, nice to meet you here. You test, can you hear me? Send your attendance, please, everyone. Okay, all right, we move on. Okay, next section of the question is structure question. Now you see what the question one. When school reopen, you sit for your final exam, you will get a question like this, This is paper 2 format. Okay, now you see. Based on the following aspect, give suggestion on how running time for 200 meters can be shortened. Shorten means you are asked to make suggestions so that the student can run faster, can finish the 200 meters in shorter time. You are asked to give suggestion now. Okay, first one, they ask you about the attire. What shirt supposed to be wear, attire. The second one, they ask you about the shoes. What shoes supposed to be wear? And the third one, they ask you about the equipment. What equipment supposed to use to let him run faster? So 3 suggestions here. So 2 marks, 2 marks, 2 marks. There are 6 marks, Okay, a lot, no. Okay, now first we look at the attire. For running event, what types of shirt the students supposed to wear? They ask you to give suggestion and then give the reason. Must have the reason, So those who involved in running event, I'm sure you know one. So what kind of attire supposed to wear? Nicole Chua, please come out. Nicole. Nicole, if for running event, right? What types of attire? The attire should be loose or should be tight or should be long or short. So which one?
Loose.
loose. Loose means he can fly already, you know, loose.
Tight lah.
Running, you see the Olympic event, right? Normally all the runners their shirt loose or tight one.
Tight.
Tight, yes, must be tight one. Tight attire must be tight. Okay, beside tight, one more, no, it must be very light. Light and tight. Okay, what is the reason? What is the reason the attire must be tight and also must be light? Okay, reason is what? Amanda, please. Amanda, come out, please. Amanda. Amanda, where are
Yes,
you?
sir. Also,
Yes,
why
Amanda. Why must
for
be?
the sir, I'm here.
Yes.
More comfortable and more easier to run because the weight decrease the the shirt weight decreases so it's more easier to run. Feel very light.
Okay lah, this one is can be accepted lah, but we have a better reason, you know. Why must wear a tight attire, tight shirt, very tight one? Anyone? Okay, if you want to talk, never mind, you just type. What is the reason of wearing a tight attire? Anyone? Just type your answer here, can or not? What is the reason actually? Shirt must be tight, very tight one. Okay, someone give the answer. Let me see. Yes, Dennis say reduce the friction. Yes, good. Correct. When the shirt is tight, the surface area is small, it can reduce the friction. Okay. All right, reduce the friction. Okay. We go to the next one. Later, I'll show you the answer. You don't need to write now. Okay. What about the shoes? What kind of shoes is supposed to wear? Okay, the shoes are supposed to be like this one, you know, you see, these are shoes lah, okay? So under the shoes, you must have something like this. One dot, one dot, one dot, one. So what is this? Under the shoes, you must have this one, you know. So what is the name given to all these dot, 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 dot? Under the sole of the shoes. Sole means the bottom part of the shoes must have something like this. So this is what? What is that? Caleb? Caleb sure no one. What is this? All this, Caleb? How we call all this dot, 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 dot here? The shoes?
The spike.
What is that?
Spike.
Spike. Spike is like the new, you know. But this one doesn't look like a new one, no. We had a... Okay, never mind. We call it stud. S-T-U-D, stud. The sole, S-O-L-E, sole of the shoes must have stud, S-T-U-D. Okay? The reason is this thing can help the runner to gain a better grip on the ground. Okay, don't copy. I will show you the answer later on. And the last one, equipment. What equipment a runner should use especially during the starting time, start events so what instrument they use so that it can pick up faster. So what instrument is that? What instrument? I'm sure you watched TV before, right? What's the event before, Hao Xiang, Tan Hao Xiang, are you there? Tan Hao Xiang, Tan Hao Xiang, can you come out? Hao Xiang? For running event, usually they use certain equipment to start the event. What is the name of the equipment? Hao Xiang, do you know or not?
Do know.
No, never mind, ask a boy. Boy should know one. Okay, let's hear from Yong Kiat. Tan Yong Kiat. Yong Kiat, please come out. Yong Kiat. Okay, Yong Kiat say yes. Yong Kiat, I don't want you to say yes or no. I want you to tell me what instrument they use to start the event. The running event, they use a certain equipment one. What was that? Yong Kiat? So that you can run faster one. So what equipment? Especially during the starting time, starting the event. So what is the name? I don't know the name, Yong Kiat. You don't know the name, Okay. Anyone can give any suggestion here? What is the name of the instrument used for runner to start the event? Yes, Dennis, very good. You say starting block. Yes, the starting block. Thank you, Dennis. Okay, now you see the answer. Now all the answers are here. The attire must be tight and light. Okay, the reason is reduce air resistance so that the speed can be increased. When the shirt, the attire is tight, light, right? So you can reduce the air resistance now, so you can run faster. The second one is the shoes. The sole with studs. Sole means the bottom part of the shoes must have the stud, okay? To ensure better grip on the ground, prevent falling, okay? A better grip on the ground. Definitely when he had a better grip, so he can run faster. Okay, the third one is equipment using starting block. Starting block, understand? Okay, starting block, the reason is to increase the acceleration now. So he can increase, he can accelerate faster. Okay, take down the answer or 6 marks, you know. Okay, you see now, for SPM physics, to answer the questions, certain question you cannot find in the books one. For example, like this question now. So it needs your knowledge, you know, your knowledge. Your knowledge in anything, everything happen in the world, okay? Regardless this is in the sport, in the science, scientific, the latest invention, as long as this is something to do with physics, then we can ask you one, you know. That's why you need to do a lot of reading now, read a lot of latest development in science. They will ask you one. Okay? Got all the answer already? Finish or not? Finish answer? Patricia, finish or not? Patricia, Joey, finish? Haris, finish or not? Haris. Hao Xiang, finish?
Yes, sir.
Finish, okay, come, we move on now. The next question. This question. Study the question, number one. This question also one of the important question. Okay, you see here. Diagram show a metal P. This is a metal. Okay, 100 degrees Celsius. That means this ball is hot one, 100 degree. Place in the beaker of water 28. The water very cold, 28 degree only. So meaning that this ball 100 degrees Celsius, 100 degree is hot. When you put inside the water, it will heat up the water, correct not? The water initial temperature is only 28, very cold. Okay, 28 degree. So what happened here now, when you put the ball inside, so the ball will release the heat. So the heat will be absorbed by the water. So the water temperature definitely will go up. Okay, but the temperature of the metal ball will drop. Release heat, so it will drop. Then the water absorb the heat, water temperature go up until a balance point. And then diagram 2, this diagram show the temperature against time. Okay, you can see from here. The graph, this is the temperature, this is the time, isn't it? So initially the temperature start from 28, the water temperature 28 lah. So when you put the ball inside, you can see the water temperature go up from 28, 30, 35, 37.5, and 40. Once the temperature reach 40 degrees, right? So it become constant. Constant, you know, the temperature reach 40, then it stop already. Constant, say at 40 degrees. Why? Why the temperature stop at 40 degrees? Why the water temperature stop at 40 degrees? Why? Why? Okay, come. Ho Wan Yin. Come out, please, Ho Wan Yin.
Yes, sir.
Ho Wan Yin, can you tell me why the water temperature start from 28, go up, 40, then at 40, then it stop already? Why? What is the reason, ma? Why it stop at 40 degrees, Ho Wan Yin? Anything like, just tell me anything. Why? Why it stop at 40 degrees?
Because it reached the thermal equilibrium.
Yes, very good. Okay. It's already balanced lah. The water and the ball find the balance already. Okay. So we say reach thermal equilibrium. Once reach thermal equilibrium, the temperature become the same, no? Same temperature. So they will stay for a certain time, they will stay 40 degrees. Okay, Okay, now the question. The mass of the metal ball, 0.4. Water, 0.2. Okay, now what is the meaning of thermal equilibrium? Okay, this question you better put inside your brain. You can come out one, definition. How are you going to describe thermal equilibrium? Thermal equilibrium. So what is the meaning of thermal equilibrium? You can see the pattern of the question now. First part, they ask for definition. They ask you to give meaning. Thermal equilibrium is what? Okay, let's hear from Lee Yishuan. Lee, can you come up, please? Lee Yishuan.
Yes.
Lee, can you try to tell me what is the meaning of thermal equilibrium?
When the temperature is 0 and the net rate of heat transfer between the two bodies is 0.
Very good answer, but you speak too fast. Okay, come. Can you repeat one more time, please, slowly?
When the temperature reaches 0, when the temperature is when it's reached the same temperature and the net rate of heat transfer between the two bodies is 0.
Yes, very good answer. Okay. Meaning, thermal equilibrium means when the two objects in contact having the same temperature. One is same temperature, have same temperature already. Then it's thermal equilibrium, same temperature. And one more, just now Lee said, is net heat transfer becomes 0. Net heat transfer becomes 0 means the heat transfer between the two objects become the same. When a heat transfer becomes the same mass, so when you minus, you find the net heat, right? So you get 0. From water go to the ball, and from the ball go to water, the heat transfer becomes the same. Once the heat transfer becomes the same, when you minus, no, you get 0 lah. So that one we call net heat transfer is 0. Okay, you see the answer now. Okay, there are 2 answers here. 2 mark, 1 mark, but you keep 1 only. But just for your knowledge, you take down both. the rate of heat transfer two bodies are the same. Same rate means net heat transfer 0 lah. Net heat transfer, you make a remark here now. Net heat transfer becomes 0. And the other one is temperature of two bodies are the same. The temperature becomes the same. Rate heat transfer, same. Same means net heat transfer. Net heat transfer lah. Very hard to write. Oh, sorry lah. Huh? Net heat transfer equals 0 lah. Okay, net heat transfer equals 0. One is net heat, one is rate of heat transfer is different one, you know. Rate of heat transfer is the same, but the net heat is become 0. Okay. Okay, come, we move on. The next, based on the diagram 3.2, what is the temperature when thermal equilibrium achieved? We already know that 40 degrees, right? You see here, 40 degrees. Okay, when thermal equilibrium reached, so the answer temperature is 40 lah. So here answer 40, just write 40 degrees. Okay, 40 degrees Celsius. Okay. And next one, what is the purpose of wrapping the beaker? What is the purpose of wrapping up? Very simple lah. What is the reason of wrapping it up? Vera, what is the purpose of wrapping the beaker with cotton? Vera?
To prevent heat loss.
Yes, correct. Prevent heat loss to the surrounding. Okay, now. First answer, 40 degrees. Second answer, prevent heat loss to the surrounding. That's why you covered it up. Prevent heat loss to the surrounding. Okay, this one okay now, stay focused, everyone, please. Just 1 hour only, very short one. Okay, next. Calculation. Calculate the specific heat capacity of metal ball, metal P. Specific capacity water 4002. Okay. In this case, you have to apply the concept like this and all. As I told you earlier, when the 100-degree ball put inside the water, so it will release heat, isn't it? The water is cold, so the ball release heat. So what you say here is heat released by metal ball equal to the heat absorbed by the water. So start with the statement like this, you write heat released by the ball equal to heat absorbed by water. Okay, must be like that. Yeah. Then heat release formula is mc theta. Heat absorbed by water also mc theta. So you put 1 and 2 to differentiate them. Okay, so you see like this. Okay. Heat supplied by the metal equal to heat received by the water. Both also mc theta. But this one put 1. For metal ball, you put 1, 1, 1. For water, you put 2, 2, 2. Okay. The mass of the metal ball 0.4. C, you are asked to find. Change in temperature of the metal ball is 100 degrees, drop to 40. So change is 60 degrees. The metal ball start with 100 degrees, then final temperature become 40. Change in temperature is 60. And for water, mass 0.2. Specific capacity water given 4002. And for change in temperature in water is 40 minus 28. Water initially 28, but finally it go up to 40. So the change in temperature 40 minus 28. Solve the equation so you get this answer. Okay, take down the answer. Yeah, finish, huh? You all understand or not? Huh? Lim Sing Yin, do you understand? Lim Sing Yin? Sing Yin, understand or not? Lim Yan Ming, understand?
Yes, understand.
Understand, okay. Leong Jian Sing, understand? Understand, okay. Come, we move on. The next question. Question number 5. Also heat. Okay, come study the question. Heat will be a lot of question one. It's an important chapter now. What is meant by specific heat capacity? Another definition. I tell you, you all better memorize it. He can ask you one, just now you see, they ask you what is the meaning of thermal equilibrium. And now they ask you, what is the meaning of specific heat capacity? Later on, maybe they will ask you, what is the meaning of latent heat, specific latent heat? A lot of things, no. Aside from 4, there's a lot of things to study. Okay, no honeymoon year for Form 4. Okay. What is the meaning of specific heat capacity? Can anyone try to tell me what is that? Okay, come, I call better call him who Mei Chen, Tan Mei Chen Tan Mei Chen, can you come up please? Tan Mei Chen, you try. What is the meaning of specific capacity, Tan Mei Chen?
The heat required to raise the temperature.
That's all. You started it correctly. The heat energy required to raise the temperature, you got certain condition one, What is that? Mei Chen? Your answer half only, half you answer half. The other half? Leong Jianxin, can you help her? Leong Jianxin? Leong Jianxin, what is the meaning of specific capacity?
Yes,
can you help Mei Chen to complete the answer?
the amount of heat required to raise the temperature of 1 kg of the substance by 1 degree.
Yes, very good, Jianxin. Mei Chen, you see, you only answer the first half, the second half. Jianxin, can you repeat one more time slowly?
The amount of heat required to raise the temperature of 1 kg of the substance by 1 degree.
Yes, correct. Is the amount of heat energy required to raise the temperature of 1 kilogram of substance by 1 degree Celsius. You want to heat up 1 kilogram of substance by 1 degree. How much energy needed? That is called specific heat capacity. Now, is here. Amount of heat required to raise the temperature of 1 kilogram of substance by 1 degree Celsius. Please keep this definition inside your mind. Don't forget this in your whole life, This is a meaning of specific heat capacity. Okay, memorize it, There are a few of you haven't sent in your attendance, so I know you just give me one. Can you send now? Send your attendance, please. Okay, this one finished. So next question. We study the question. A beaker containing 250 gram water. So the water here, 250 gram. Initially at 26 degrees, the water temperature is 26. Heated with a 500 watt electric heater. This heater, the power is 500 watt. Heated for 1 minute. 1 minute is 60 seconds. The final temperature of the water after 1 minute was found to be 51. Okay, you see. Initially water 26, but after 1 minute of heating, so it raised up to 51. It become hot, 51. Yeah. So now, same question again. They ask you to calculate the specific heat capacity of water. Water, you should know the answer already. It's supposed to be 4,200, correct not? Specific heat capacity for water is 4,200. Standard value, I told you in the class already, not to memorize or not. Specific capacity for water is 4,200. Okay, now they ask you to calculate. You cannot just say 4,200. You must calculate. No, maybe your answer is not 4,200. So you calculate. So how to calculate here? Now you see now. In this case, the heat is supplied by the heater. When the heat supplied by heater, so you start with PT, power, multiply the time, PT. This one is a heat supplied by heater. You use the power, multiply the time in second. PT equal to heat absorbed by the water, of course, is MC theta. Okay? Right. Use this formula, put in the power, put in the time, put in the mass, put in the theta change in temperature. Now you go and find the C. You're asked to find the C. C specific capacity for water. So to find C, you take PT divided by M theta. Okay, please do it now. Everybody, do yourself. To find C, you take PT divided by M theta. Okay, calculate now. Put in the power, put in the time. Remember, the time must be in second. Okay, put in the mass in kilogram. Theta change in temperature. You already here, you can see, right? Okay, calculate, see what is your answer. Do it, everybody. Okay, don't wait for the answer. Okay, one answer. Lim Yan Ming, do you get the answer? Lim Yan Ming, one answer you get? Lim Yan Ming.
It's heaven later.
Heaven, okay lah. Okay, come. Xin Ai Ling, do you get the answer? Ai Ling, Xin Ai Ling. Ai Ling, Xin Ai Ling, one answer you get?
Oh, yes, sir.
Not yet. Esther say answer 80. The other, please check. I think 80 is not correct, 80. 4,800. Lakshmi Chong. Lakshmi Chong say 4,008. I think it's correct. 4,008. Esther 1, you are very funny. So, okay lah. Check your answer now. Okay, the answer is yes, 4,800. But the unit mixture is like this, Joule per 1 kilo per 1 degree. Just now we say is 1 kilo, 1 degree, right? So the answer is Joule per 1 kilo per 1 degree. Joule per kilogram per degree Celsius. Yeah, actually this one is PT power multiply time divided by m theta. Okay. Power 500 time 1 minute 60 seconds mass and change in temperature. You get 4,800 joule per kilogram per degree Celsius. Yeah. Mok Chui Sian. Okay, understand. Mok. Mok, where are you? Mok.
Yes, sir.
Understand. Mok.
Yes.
Good, Mok. Now, Esther, now you understand what is your mistake, Esther? Okay, finish. Okay, come, we move on. This one we done already. The second part. A more accurate values of specific capacity is 4,200. I told you, right? Water supposed to be 4,200. But you never get. You get 4,008 just now. Okay? 4,200 is the calculated value bigger or lesser? Of course, it's bigger lah, but because you get 4,800, isn't it? So here you write bigger. It's bigger, okay, Okay. Bigger actually is normal, you know. In class also, I told you already, right? When you calculate, you did the experiment to get the specific capacity value, right? You always will get the bigger answer. You won't get a standard value one. Understand? Regardless this is water lah, aluminum block, you won't get the accurate answer one. Your answer must be bigger than the standard value. Okay, like water 4,002, but you get 4,008. Bigger, correct not? Now the reason why is normal that you get a bigger answer. Why it is always normal you get a bigger answer? Like? Why? Tan Eng Sing, Chan Eng Sing, sorry. Chan Eng Sing, are you here? Chan Eng Sing. Chan Eng Sing here or not? Yes.
Yes.
Chan, can you explain why the answer you get is bigger? Like?
Because heat loss.
Yes, correct. Because heat loss are sure happen one. How you cover, how you wrap, it still can happen. It's because of the heat loss, it will make your answer not accurate. And then your answer will become bigger. Okay? Okay, come. This part you really need to understand. Or you look at here just now. Look at this formula. Because of heat loss to the surrounding, right? When you carry out the experiment, okay, heat loss will only affect the theta value. It will make the change in temperature become smaller. Because power is fixed one, time is also fixed. The mass of the water is also fixed. The only thing affected by the heat loss is a theta, change in temperature. Because heat loss, heat run away. So the change in temperature become less. Supposed to be temperature go up by 40 degrees, but because heat loss, the temperature only go up by 30, become less, isn't it? So when the theta becomes smaller, when you calculate, you divide by a smaller number, your answer will become bigger. That's why you get a specific capacity always bigger. Bigger, understand? Because this one's too small, smaller than the expected value. So your answer here will become big. Sid Eiling, understand?
Yes.
Understand, Mok, do you understand? Mok,
Yes, sir.
where is your good friend, this, you Jia Jia? Jia Jia here or not? Jia Jia never see your name, no?
Yes.
Jia, do you understand?
Yes.
Can okay, come. Please write the answer now. Okay. Here, answer picker. The reason is heat loss to the surrounding during the heating. This caused the rise in temperature to be less than what is possible. The smaller the increase in the temperature causes calculated value of specific capacity to be bigger than expected. Okay. Copy the answer now. Please, everyone, don't sleep. Wake up, wake up. Teaching online are very difficult because I cannot see you on, cannot see your face. Cannot see you, don't know what you are doing there. You are playing handphone or you are paying attention. I also playing handphone. But I play when I rest only. Yeah, finish. Okay, last part of the question. Suggest one modification to the apparatus to get better value. Just now we say our problem was heat loss because heat loss caused the answer not accurate. Now can you do some modification to get a better value? So what you must do, you see the diagram, what is left? Can you look at the diagram? What are you supposed to modify? You see the diagram here. What you must do to make your answer more accurate? Lim Yan Ming, please answer. Yan Ming. Lim Yan Ming, are you there?
Yes.
Yan Ming. What you must do? What you must do to make the answer more accurate?
Cover the figure with cotton.
Yes, correct. Wrap the picker with cloth. Esther 1 is correct. Thank you, Esther and Yan Ming. So the answer is here. Okay. Reduce the heat loss. The picker can be wrapped or put in an insulating material such as cotton. You either cover it with cotton or you put in a cotton, then you wrap it up. Okay. Okay, got the answer already. Now you can left a few minutes only, 1 hour very fast one, no? What lesson you all have? 10 o'clock, what lesson you all have? Sid Eiling, what lesson you all have?
Modern maths.
Modern maths. What about 4 science 1? 4 science 1, what lesson?
Same. Same.
Modern maths all same, combined. Okay, is it same teacher?
Yes.
Okay. Well, your physics same, then modern maths also same. Okay, come, we move on. Now question number 6. This chapter you just learned, is optical, light and optic. Diagram show a car side view mirror. This is a side view mirror of car. Fitted with another small mirror P. Okay, I'm sure you have this experience now. Normal car is this lens only, this mirror. But in certain car, you see people fix another smaller one is here now. Okay, let me explain to you actually for normal car, this side mirror, this one is flat mirror. Normal car, this is flat. Then whether this small one is curved mirror, is curved shape one. Okay. So the curved mirror here actually help to increase the field of view so that the driver can see bigger area lah, because it's curved shape, convex shape. So you can increase the field of view. Whereas this flat mirror, like just like normal mirror at home lah. So flat, so you can see certain area only, Okay. First, name the phenomenon involved in the formation of image. I say many times already. In mirror, right? What phenomenon involved? Formation of image. For mirror is involved what phenomenon? Okay, the phenomenon you learned already in your lesson was interference. You learn, right? Interference. You learn diffraction. You learn refraction, the light band refraction. And one more you learned was reflection, reflect. So 4 things are reflection, refraction, diffractions, and interference. Okay, in this case are the mirror or which one? Mirror involve which one? Okay, someone answer already. Yes, Lim Yan Ming say reflection of light. Yes, correct. Reflection. Okay. Reflection of light. Mirror can only reflect the light. Reflect, then form the image. Okay. The next question. This one I already told you to memorize one. What are the characteristics of image shown? Okay, characteristic of image here. Mirror lah. When mirror form the image, right? What are the characteristics of image formed by the mirror? Memorize, you don't memorize this one, susah, no? When mirror form the image, every morning you look at the mirror, you see your image inside the mirror. So what are the characteristics? The answer is what? Okay, I want to go faster lah. Now it's here. It should be upright, virtual. The mirror one is virtual, behind the mirror. Same size. For plain mirror lah, plain mirror same size. You see yourself, your image inside the mirror same size with you, isn't it? Same distance, same size, same distance also. Okay, and one more time, one more is laterally inverted. I hope you know what is that. Wait, still remember what is laterally inverted or not? What is laterally inverted? Mu. Mu. Can you come up? Mu.
Yes.
Mu. What is the meaning of laterally inverted? Can you tell me?
Yes.
What is laterally inverted? Mu.
Don't know.
Don't know. Laterally inverted. Okay, try lah. Try to think why cannot? You Jia, what is laterally inverted?
Yes.
What is laterally inverted? Jia?
Wait.
Wait.
Left go to right.
Yes, correct. Left go to right, right go to left. So you say left, right interchange. That is called laterally inverted. So all these answers, remember, these are the characteristics of image formed by the mirror. Particularly, this one is for plain mirror. Okay, come next. This one. When you see the wall clock through a mirror, the pointer like that, actually, what is the time? When this is a wall clock, you look at the mirror, you see the mirror show the wall clock, the time is like that. So what is this time actually? What is the time shown by the wall clock through a mirror? Jok Ke Yin. Jok, can you come up, please? Ke Yin. Jok Ke Yin.
Yes, sir.
Jok Ke Yin. Can you tell me now, when you see a mirror, you see a clock like this, so actually what is the actual time? What is the actual time?
8 o'clock 05 ah.
Yes, correct. Very good. Thank you. Okay. 8:05. 8:05. Okay. When you see the clock need through a mirror, you see actually the time 8:05. Yeah, 8:05 now. Okay, next one. Next one is formation of image. You see, this is a convex mirror. This is mirror. So mirror will form the image when the light is an object. Hit the mirror, get reflected, reflect through focal point. You see, the focal point is behind. It will reflect the light from here, from this point. Another line you draw is from here, connect to C, center of curvature. You must know this line, center of curvature. So it will hit the mirror and then go back. Come back, same line one. You go to C, understand? Hit the mirror, can reflect. So intersecting point is behind the mirror. So this is an image. The image is here. Okay. So first question, what types of mirror? What is the mirror there? What is the name of the mirror? Marvin. This mirror what is the name? Marvin Chan. Where are you, Marvin? Marvin Chan. What is the name of this mirror?
Concave mirror.
Concave.
Convex mirror.
Center fat one, is convex mirror. Yes, convex mirror. Okay, it's convex. Convex mirror. Okay, next one, draw the image. No need now. The image is already there. Okay, you just label. This one is an image. The image is here. It's already in the diagram. So this is an image. Please put a remark there. This is an image. And next, they ask you characteristics. No. Okay so I think for today I stop here class, because 10 o'clock I got another class. I need to get ready okay, because the moment I stop recording it takes some time to download, then only I can start another lesson. I need to keep my computer some time to download the file. Okay, because while downloading I cannot do other things computer cannot do, so I cannot start the new lesson. Okay, so I stop here for today. Okay, for size 1. Anyone here haven't sent your attendance? Can you please send your attendance, everyone? Okay, I need to take a picture first. Okay. Send your attendance. If you haven't sent, please send your attendance now, everyone. Yeah. So please take good care of yourself. Focus, stay focused because now it's still schooling day, so have to stay focused Okay. So thank you everybody for joining this class this morning. Okay, I really appreciate it when you join my lesson. Okay, so I see you again next week. Okay, bye-bye. For size 1, for size 3, bye-bye. Okay, bye-bye.
Thank you, sir.
Thank you, sir.
Bye-bye. For size 1 and 3. Okay, bye-bye.
Thank you, sir.
Okay, bye-bye. Go and have a rest first before you start the next lesson. Okay, bye-bye. Okay,